Hello and welcome everyone to this past Marathon Analytics. We are excited you could join us today for Diego and Cormac's session, the new ML Lifecycle, Deploying and Managing Machine Learning. This past marathon features back-to-back live webinars delivered by expert speakers from the past community. Note that the sessions will be recorded and posted online after the event. You will receive an email letting you know that the recordings are available. My name is Jamila James, and I'm excited to hear today's content. But before I get to that, I have a few introductory slides before I hand over the reins to Diego and Cormac. If you require technical assistance during the call, please type your request into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you can ask questions throughout the presentation. Feel free to enter your questions at any time. And today we're going to do things a little bit differently. So if you have a question and it's relevant to what Diego and Cormac are covering, they will go ahead and address the question throughout the presentation. And if we have a chance, we'll get to the other questions at the end. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. We love evaluations. There'll be a pop-up window after the session, and we just need your feedback because it's really important for us to capture that feedback so that we can make future events better. And in case you didn't know, you can keep learning all year long from PASS. Just go ahead and visit pass.org and check out all the free educational resources available to PASS members where you can connect, share, and learn. This session is presented by Diego Oppenheimer, CEO of Algorithmia, and Cormac Foster, Product Marketing, also at Algorithmia. Diego is an entrepreneur and product developer with quite an extensive background. He has previously designed, managed, and shipped some of Microsoft's most used data analytics products, including Excel, Power Pivot, SQL, and Power BI. His co-presenter, Cormac Foster, is a former member of PASS's board of directors, and prior to working at Algorithmia, he was a senior product marketing and communications manager for Microsoft. So without further ado, here is Diego and Cormac with the new ML Lifecycle, Deploying and Managing Machine Learning Models at Scale.
Thank you, Jamila, and hello to everyone, and hi to the PASS community. I missed you folks. It's nice to be back again. I will be handling kind of the blocking and tackling for the most part through this, fielding questions, that sort of thing. I will let Diego go ahead and do most of the content because he's probably who you're here to hear. But to start with, just to get a feel of the room, we'd love to start with a poll. Just to kind of see where you are with machine learning and model production deployment. And that will help us tune the rest of the presentation so we know what to talk to. We'll keep that up for, I'm guessing, probably about 30 seconds as we go forward. When we talk about production, what we mean is really getting models off of your laptop or wherever you've developed them and making them available for access by other models or other applications so that you're not just generating your inference and putting it, say, into a dashboard or into a report that you're emailing, but you're actually taking that model and allowing it to be consumed or its output to be consumed by other applications and other developers. So I'm guessing we'll probably have that up for just a few more seconds. So if you could get your votes in there. And then as soon as we have those results in, I will hand them off to Diego. Excellent. So the results that we have in there, just for Diego here, about 50% are either have 0 models in production or are currently building them. And then we have numbers scaling down from there. So we have a lot of people who are looking at ML for the first time, which I think is probably a really good time to have this discussion rather than when you have 1,000 of them. So I will hand it off to Diego to talk about some numbers from a survey and what life looks like right now for a data scientist.
Great, thanks very much, Cormac. So first of all, hi everyone. Really excited actually to be back talking to the PASS community. I was just talking with Cormac, and I think the last time I presented during PASS was introducing Power Pivot, which would end up being kind of like the initiations of Power BI at PASS, and I want to say 2011. So really excited the world comes full circle on this one. So one of the things that to talk about here and kind of like set the context is, if we think about the world of BI and it being really, oversimplifying it in the world of saying, hey, we can analyze a whole bunch of data and we can explain what's happened in the past. The world of machine learning is really about predictive analytics, really about trying to see if we can actually find patterns in data so that we can move forward and see new situations and have a higher or low level of confidence on what we think they should be, the prediction or the classification of that data. So the way that I think about the world and is, we've been doing the world of BI and analytics for quite a long time, and what we're moving into this new world of machine learning is really an extension of that world in terms of like what are we trying to do, as well as looking at the infrastructure that we already had in place for traditional analytics, as well as the infrastructure that we had in place for traditional development, and how that evolves into this kind of idea of a new machine learning lifecycle and the challenges, but also what we think we need to be paying attention to. So the core part of it is that we looked at the personnel, and so we did a survey and we did look at the personnel. We looked at data scientists, machine learning engineers across over 500 surveyors in large companies across the globe. And what we found, which is not really surprising, that in very similar results that if you from the early days of BI, you would have thought the same thing, except you change the names around to DBAs and IT, that 75% of the tasks that the data scientists are really going to be like focusing on were really being focused on actually doing infrastructure and building infrastructure. So this was things around connecting data sources, getting the data sources, cleaning the data, building machines, dealing with VMs, figuring out how to do authentication and security. And less than 25% of their time was actually building the models and doing the model training and analytics, which is really what they were being hired to do, really what their specialty was. And so what we looked at a little bit deeper, we started figuring out, hey, what were those key challenges that, why were they spending so much time, like this large amount of time building infrastructure? And they kind of dropped into three major categories. One, production at scale. So getting a model running behind an API might be fairly straightforward, but actually doing the scale of a mission critical system, might be like a loan application app that's going to point of sales, or HR system or a CRM system, that are required to have a certain level of uptime. That became really complicated. Model management, new versions of these models, and we're going to talk a little bit more about like the iteration that goes into these models, and every single time there's a new iteration, there's a new model, and how do you scale that model, and the versioning, and how do you keep track of it. And then the rest, which is, we're really in the early phases of data science, machine learning as a whole. There's new frameworks coming out on a daily basis. So for those of you who are fairly familiar with the space, if you want to take an example of deep learning as a good example, we were all talking about TensorFlow a couple of months ago, then PyTorch came in and really has been going at an immense growth rate. If you look at the different statistical packages, how, before everything was in SPSS, now everything's in R, now almost all the libraries are coming out in Python. So how do you deal with that, different languages, different frameworks, the heterogeneity that really is implied? And that's these are the three big categories of complications or time that's being spent, getting these models in production, which is really the end result. So, talking to Gartner, really if we think about the value chain, and this is, again, for those of you who are, deeply familiar with the analytics stack and the BI stack, until you actually can analyze the data, until you can actually look at it and create the reports and build it, there's no ROI on your investment. So you could have spent all the money in the world building databases and cleaning data and schemas and creating models and hiring data scientists, but unless you can actually attach this to a business application where you're going to actually get the ROI, there's no business value in that entire spend chain. And so one of the things that we saw that Gartner actually in their survey came up with is that the main barrier across to actually getting business value out of the data science and machine learning efforts seems to be locked in to actually being able to deploy into the processes and actually real live applications that are necessary. So if anybody loves reading academic papers, I highly recommend this one from Google. So it's called The Hidden Technical Debt in Machine Learning Systems. And really the core thing of that is that they explain is that the difficulty in machine learning is rarely, and complexity is rarely really the ML code itself or the machine learning code itself, but actually all the infrastructure around it that is necessary to build to be actually doing successful machine learning projects. So that includes data collection, feature extraction, process management, how you're going to serve these models, how you're going to monitor them, how you're going to resourcing, what the analysis tools are. So the ecosystem around these predictive analytics tend to be the kind of long pole of all the efforts and why they need to be focused on, because I'm not saying that the ML code is easy. It's just saying that for the people who have the specialty on that, it tends to be actually the smallest time consumption of the entire process that is spent there. So let's talk a little bit about the life cycle. So what does that look like? So the first thing that you have to do is you need data. So we talk about, people love talking about how data is the new oil, and without data you're not going to be able to get any sort of good predictive analytics. With bad data you're going to get bad predictive analytics, and so data is at the core of it, really the most important thing. And so you're going to go from data management systems. So these are your traditional ETL pipelines, your data lakes, your transactional systems. How you actually are cleaning and building out the schemas is going to be a core part of your ML lifecycle journey. The second piece of that is, once you've actually figured that out, you're going to actually go and look at the the training, which is how am I going to connect to those data systems, how I'm going to use the different training systems. It could be Jupyter notebooks, I could be using things like H2O, I could be using things like a Cloudera workbench, or some of the Azure tools. And then once I've actually had those models up and running, I want to actually run them, deploy them, manage them. So how do I actually scale those out? How do I actually allow my applications to use them at the speed and inference and size that they able to do it, so I can have those apps consumption in. And obviously these deployment system and management systems need to be able to connect back to the data systems, which are just as important. So let's start talking about the challenges involved. So I talked a little bit about heterogeneity. And so one of the things is that realistically that data, specifically machine learning models and machine learning efforts, they're rarely a one model thing, right? So there's pipelines involved. And when you have pipelines involved, there's going to be multiple different kinds of things that go into those pipelines. And so the heterogeneity is really about the fact that I might be using a framework in one language like Python because that has the best statistical library that I need, but then I want to complement that with a classifier in R, which might have a different kind of library that I need. In some cases, I might be using CPUs. In some places, I might be using GPUs. So the fact that today's state of the art of machine learning is actually really around dozens of frameworks, dozens of combinations of those frameworks, lots of different hardware dependencies, lots of different languages are involved. This adds a level of complexity for actually getting into production that your system actually needs to take into, around that. So the next one is really around composability. So when you think about it, as I mentioned before, none of these things live in isolation. So we have a great example here of a scanned document going into a OCR text extraction where language is being identified. If the language is in English, I might already have some tools for English language. If not, I need to translate it into English before I move it down into a vectorization or a sentiment analysis pipeline. But the more important thing is that each one of these components realistically might be in a completely different language, completely different framework, and in most cases managed by different teams inside an organization. So your system around productionizing and running machine learning at scale is going to be able to have to deal with this heterogeneity, as well as the pipelining, and understand how those pipelines get put together and scale those pipelines together from an infrastructure perspective. So performance is another big challenge. So, SLAs, so in a lot of cases, and we've all lived that, I have my report and I hit refresh on the report, and it might take an hour and a half for that report to build out, and that's fine. All I need to do is kind of load up the KPIs. That's typical in the BI world. When we're looking about predictions and recommendations, we might actually have an SLA that is in the milliseconds or in the seconds, where I actually care about how quickly the system's returning, how fast I can actually scale that. I like using the example of recommenders on the front pages of websites. So there's about 7 seconds of attention that a user gives to a website. So you actually have to do everything that you do on a website loads in 7 seconds, which also means that you have to be able to return results from your predictive analytics and way under that. So in a lot of these cases, what the performance needs to look like, how that performance needs to look like, is very tied into the experience of the application that's consuming these machine learning models. And therefore, you have to start being able to tune that, and you have to be able to take in different considerations around it.
Yeah, so we have a question actually from the audience on that last slide. Is anyone actually trying to mandate standards, language, framework, et cetera, to reduce the complexity of that pipeline to make it easier to manage?
Yeah, so I think mandating standards in this particular case is going to be really hard. And a good example of actually looking at that is what's happened in the normal development lifecycle. So different developers use different IDEs, they use different frameworks, they use different, they want to bring in the tools that they're comfortable with. There's a question there of how do you standardize on the pipelining? So your system of actually building the pipelines, your system for actually building the applications on the backend should be able to take all of these heterogeneous inputs, but then actually provide a standardized way of deploying them in production and scaling them. So it's really a question of, you have to still allow the creators to use whatever tool they're comfortable with, but give them a path to standardization kind of on the back end or production end of the system.
Awesome, thank you. And for anyone else with your questions, again, we'll try to answer them in line like that as they come up, but feel free to ask them now, and we'll have time at the end as well. So this is, so getting back, so sorry for the jump there, but we're back to the performance issues. We're talking about how you might solve some of those.
Yeah. So how do you actually look at these? So when you're looking at pipelining and performance issues, one of the things that you can actually start doing is, well, let's start doing evaluations on metrics across multiple models. So a good example of this is, we get asked a lot, like, hey, should we run this model on CPU mode and GPU mode? And and my answer will be like, well, it depends. So maybe there's an acceleration on GPUs. Maybe it runs twice as fast. But maybe the cost is 4 times as much. So then the question is, for the doubling in speed, are you willing to pay 4 times the cost? And the only person that can answer that is really the person that has the business understanding of what does it mean. If there's an SLA that you'll be under for 4 times the cost, it might make sense. If you don't have an SLA, then you don't care, right? And why would you actually pay the cost? So being able to have suites around evaluating them, doing performance metrics, understanding how those models load dependencies becomes a really important part of actually being able to productionize these models. So another challenge is lack of reusability. So for any of you that work in a large company, you've definitely heard the left hand not talking to the right hand concept inside the organization. And it gets even once you're actually building the exact same thing over and over again in an organization. So this actually happens quite a bit in the analytics world and in the machine learning world, where you'll have a team, for example, building a model against their data, against their user data, where they're extracting certain insights. And another team on a different part of the organization wants to actually use the exact same thing, but they don't know that this other team is building it. So, how do you actually, extend that? How do you show the teams, what that they're building the same thing? And in the worst case scenario, if multiple teams are building the same thing, now there's different versions that have different behavior and there's no consistency. So really what you want to try to do is really expand the accessibility and discoverability of these models within your organization. And so a good way of doing this is through API endpoints is for accessibility. So while you generate API endpoints, you can have multiple languages consume the exact same model in a different way versus making it language specific. And then what you can do is start building repositories around your assets. So in the same way that you want to be building models like repositories around your analytical assets, looking at machine learning and saying, hey, we've built this IP, we've built these models, how do we actually track these assets? How do we make them searchable? How do we actually put them into a findable way inside an organization becomes more and more important. And then another way of encouraging reusability is through documentation, code snippets, and then using other resources for discovery like recipes, etc. So what you're really trying to do is say, hey, it's really hard to build these analytical models, these models. We really don't want to be spending time in the organization building them over and over again. We need to make the effort to make them as reusable as possible. So modularize them, make them discoverable, add documentation to them, and then obviously security becomes an issue, like who can access what, so you want to be able to add role access-based controls to that. So the iteration speed. So this is a really interesting concept because one of the things that we are not used to is at the speed at which machine learning iterates. So for those of you who have been in software world for a while, if you think about a traditional software, and I would say even a traditional analytical workload where you're building an analysis, around that, what's going to happen is you're iterating, you're building a model, you're building an application, you're going to test it, you're going to deploy it, and then you're going to monitor it. And maybe you do that once a week, once a month, once a year, once every a couple of years. In the world of data science, because the data is moving so quickly and changing, the iteration speed is much, much faster. And it's actually like, you can actually see that like multiple times a second, multiple times a minute, where you have to go through this deploy, connect, scale, around the system. And so the iteration speed that happens inside machine learning workloads is a lot faster. So now you actually have to have the tooling to be able to accept that iteration speed so that you can actually work through those.
So we have a question, actually going back a couple of slides. There we go, about the confusion matrix and some of the terms there. Some folks who weren't familiar with TP, TN. So what we're talking about there are true positives, true negatives, false positives, false negatives. And these are just some of the ways that people might calculate success. I think to me, when I first got involved in the data science field, and people talked about accuracy, I just assumed that accuracy means something very specific. And to you folks who are statisticians, you already knew that. But to me, that was new. So these are just some of the metrics that could be important. And so let's say you're a financial services firm, and you are doing let's say you're doing a fraud screen in real time. The most important thing to you may be fine having a couple of false negatives and letting those through if it means that you're going to complete the transaction, the round trip, with low enough latency so that people don't abandon the transaction. If you're running the exact same model, but you're a forensic auditor, it doesn't matter how long it takes. You just want to make sure that you identify all of the people who might be potentially committing fraud. So that's an example, maybe not the best one, but that's just an off-the-cuff example of how these and other variables could factor into what makes a success and what doesn't.
So we talk about, kind of how do you actually deal with the, kind of this iteration speed and the scale that would cause it. So if I'm creating a new model every couple of minutes, every couple of hours, the mess that could generate is really, really massive. So what we want to do is we want to always ensure backwards compatibility for all models. Every model should be callable, even if no longer available. We want to really enforce semantic versioning. So let's borrow from the best things of the API and development world and bring them to the world of data science. We want to be able to version all the associated metadata and information, including the documentation. And then let's actually use some standard architectures that allow for this really well. So, we've been advocating for a while that, using Git as a way of really versioning and productionizing like machine learning code and machine learning models is a really, like, we already have this, we have workflows for it, and it works really well. So we should bring and borrow the best from, the API world, from the development world, and bring it to the analytics. Because the way that I really see the world of machine learning as this marriage between traditional analytics and the development world. And so I like to say this a lot, and a phrase I use internally here, which is like, the machine learning lifecycle compared to the software development lifecycle. It's the same, it's a lot of the same, but slightly different. And so, but we can borrow a lot of the best practices and bring them to them, which becomes really interesting. So one of the things that's also slightly different that is worth kind of touching on is how different the two stages are from in the world of machine learning, which is between training and production. So training is when you're actually grabbing the large data set, you're iterating it through it, you're actually building a model, you're trying different hyperparameters, you're essentially doing the different techniques that are trying to get you to a highly accurate predictive model. This is usually a single user, like a workflow, really long compute cycle, fixed load. So you essentially are going to scale out your cluster. It's going to train on a bunch of machines. It's stateful because it has to index itself. And then in most cases, it's single user in the sense that like there's somebody triggering the job. The flip side of that is that once you have the result of that, a serialized model that's going to be run, it's really doing classifications at that point. So it's short bursts of intense compute, although in volume it might be 100x larger than anything that you're doing on the training side. It's highly elastic because it's usually tied to some sort of traffic parameter. It's stateless in the sense that every prediction is not tied to the previous prediction. And in most cases, it's many users because this might be a model that's being called by 100,000 mobile phones. And so there's just like architecturally really, really big splits between what the training and the production side of things are. So you have to think about the architectures and developing these in a different way. So one of the things that we like talking about here is that, like we think that, so for those of you who are not familiar with the concept of serverless, there's still servers involved. I personally hate the name. I didn't invent that. Nobody asked me, sadly. So think of it as just-in-time computing. So making available the resources and compute just in time for when they're needed so that you actually can have the most efficient usage of the computational power. So if you think about traditional capacity planning, and anybody here from the past world who has done, big build outs of analysis services, you remember doing like, how do we build out the capacity for this? How many machines are going to be needed and stuff like that. So it's pretty wasteful. It's very expensive because you're essentially always designing for the max, right? So you're saying, well, at the max capacity, I need this, so I need to make all of this available, but most of the time I'm not going to be using it. So then you can actually do local maximum planning, which is this idea of kind of like rolling scale up and scale down. So as traffic is coming in, scaling up more machines, slightly, but you're always looking for the kind of like you're subdividing the maximums, right? And you're saying, okay, in this period of time, what the maximum is going to be in this period of time. So it's still inefficient. It really increases a lot of the management overload. When you look at a serverless, function for this, what you're really seeing is a massive efficiency boost because you're saying is as long as I can scale the machines or the models just as quickly or within like very close to how much demand there is, I'm going to actually be able to use exactly the highest efficiency possible of my predictions and the infrastructure that I'm using behind that. It actually also provides a lot more scalability because it allows using the resources to their maximum usage. So like there's a really good way of actually doing predictions at a high efficiency using serverless. So then we get into the fun part because absolutely everybody here loves compliance. It's everybody's favorite subject around analytics. Once you actually have an internal model, and how it's being used, you have to be able to answer the questions, who calls what, when, with what data, and at what time. In some cases, you might be in a regulated industry like financial services, where the SEC could come in at any, or regulators could come in at any time and say, hey, why did this happen? What was the prediction? Who called the data? What were the answers? In pharmaceuticals, you know, especially in things like drug discovery, the FDA might come and ask the same thing. So we're starting to use machine learning in a bunch of these different areas like financial services and pharmaceuticals and regulated industries. We have to be able to provide auditability and compliance, and also be able to actually do kind of separations from a security perspective around that. So building a system that can actually do chargebacks and attribution. So again, what I mentioned, who called what model at what time and with which data, being able to provide reporting to internal accounting on who's using the systems and how they're using it, and being able to provide that data easily, and then be able to extend themselves into your current systems of record around compliance and auditability becomes extremely important. So when you're thinking about the life cycle and the systems that you're going to be implementing there, you need to understand that these are the considerations that you're going to have before you can actually have a truly production-ready system. So one of the things I want to talk about is kind of like you know, a case study. So we've talked about you know, we talk about the roadmap to machine learning maturity, and this is actually something that you can go to our website. You can download this map. It's completely product agnostic. It has nothing to do with our product. So if you want to actually go check out the roadmap for machine learning, what this allows you to do is kind of track down where you are on your journey from a maturity perspective, on the data side, on the training side, on the deployment side, on the management side, the 4 real categories. And then look at where you want to be and what are the steps and paths you need to take to be able to get there. So in this case study, so this is a financial services customer of ours, you know, they had significant investments in their data warehousing capabilities and their data lake and ETL system capabilities. They had starting to work with individual groups on data science. So they were actually doing training of models, building some regression models, building some you know, neural nets around natural language processing. But every single time they needed to deploy their models, they needed to do it manually, and they would integrate it directly into their application, which meant the life cycle of actually getting a new version of the model. So think about that. I build a model and I put it directly inside the application. So we just talked a couple slides back about how these models get iterated then potentially multiple times a day or multiple times a week. And now we're saying that they get embedded in an application that in a bank, which might take 2 to 3 years to rev. So that dichotomy right there is really, really expensive and really bad for the world of machine learning. So you have to kind of break that out so that you can actually allow that iteration to be a lot quicker. So the final result, as we've helped them get into their kind of like larger maturity cycle, has been, you know, really provide them an automated way of doing deployment, provide full CI/CD applications. So as a new model gets built, that's continuous integration and continuous deployment. It allows us to actually deploy the models in an automatic way. We want to decouple the app and the model releases. We provided them with ongoing security audits through the management layer, and with 2 times the data scientists and 4 times the models in production, we'll be able to achieve unblocked by actually increasing the maturity around that. So some best practices from our learnings over the last couple of years, really design your infrastructure to be able to execute at scale repeatedly and efficiently. It's a great place to start with having a recipe. Hey, we're going to build a Flask app and we're going to build, and this is the recipe to do it. But that's not a really, that's a repeatable, but not a scalable order and efficient way of doing it. So it's fine to start there, but just think about how am I going to get the scalability, repeatability, in an efficient way. Think about these systems, and these are a lot of the learnings. Any of you who have been in the BI world, like you'll learn this you've known this, which is think about these systems as tightly integrated but loosely coupled. I'm going to change the visualization engine. I'm going to change the training system. I'm going to change the ETL system. These things are going to come in and out, and so I want to be able to tightly integrate them through programmability, but allow them to be loosely coupled in the sense that if I need to upgrade a component or change a component, I can easily replace that in or out. Really anticipate that you're going to be using a lot of different tools and technologies to be used concurrently and at every step of the life cycle, and really remain open to integration with a variety of in-house technologies, different data sources, different authentication systems, different compliance systems, different monitoring systems. So when you're designing your infrastructure for ML, just understand that you're going to want to integrate with all these in-house systems as much as possible, or go find a vendor who can actually give you those kind of integrations, which is just as important. And then things to think about in the ML infrastructure components. So having a model registry, I think, is really important. A comprehensive catalog, model catalog that can be used across your organization, easily searchable and found by every data scientist, fully documented. And then that gives that API infrastructure for running those models on demand. Providing connectivity and extensibility. So how do I'm going to do model pipelines and APIs? Depending on your organization, does it cover my cloud-based infrastructure as well as my on-prem, data sources infrastructure? Providing the DevOps learning and monitoring systems that you're going to require for anything that is a mission-critical production system. And then integration into third-party tools like Jupyter Notebooks, which is the preferred place today for data scientists.
So we have a couple of questions on the last couple of slides that have come in. The first one is about CI/CD. So what does that look like in actuality? Like if you have developers who are doing their own development and you're doing what you're doing, what does that pipeline look like and who's involved?
Yeah, so you can use a lot of tools of like the ones you use today. So things like Jenkins and Travis are great. What you really want to do is you want to provide a way for a data scientist to push a new version of the model, and whatever tests need to be run against that model, they can be run automatically and programmatically. And then once those pass, they can go directly live. A new API version gets created so that an application can start consuming that immediately. So the automation of that process is really what I mean when we talk about the continuous integration, continuous deployment.
Okay, the next one is, the next two are kind of related. The first one is about the roadmap. Do most companies look like the company you showed me? Where do they start?
Yeah, so I mean, I talked about it earlier. If you don't have data and you haven't figured out your data story, that's the place to start. Like just with analytics or with in machine learning, like if you don't have a good data story, like that's the not start. So you have to start with getting to a world where I have access to the data and I have access to good, clean data. That's always step one. Once I have that is when I can start thinking about like, okay, how am I going to use this data? What's the business reason that I'm trying to like figure out? So let me actually retract that. Before the data, figure out what you're trying to optimize for, right? So machine learning is a optimization technique. I want to increase revenue. I want to decrease costs. Whatever that is really about what the business at the end of it. So what you want to do is really focus on, okay, what's the business outcome I am trying to do and achieve through potentially machine learning? Okay, now that I've actually figured out what the business outcome is, what's the data that I need to be able to produce that? So do I have that data? Is it clean? Do I have an ETL system that goes with it? Once I have that data, now I can train a system. I know like, okay, well, if my goal is to increase, retention by X%, now I actually know what I'm training and optimizing for. So I need a model that's going to predict that. And then I can actually start thinking about that production and the management of that model. So it all starts with what's the business value I'm going to get out of this effort and how am I going to design for that business value.
Okay, awesome. And one more, also kind of related to getting started. This sounds like a lot. What do I, as a data analyst or data scientist, do to make my work have a bigger impact? So I mean, I guess there's a lot to implement there. If you are producing things on your laptop, how do you go about, I guess, as an internal champion, getting them into deployment and allowing people to take advantage of this?
Yeah, so I mean, I think with any of these projects, this is why I say focus on the business value, right? Because if you can show results, even on a laptop, say, hey, look at what we can do, right? We have this model, it's going to give us a lift in sales of X%. I have the data here and I've proven it. Now it's a great way you can say, okay, evangelizing that as the objective, you can now bring in teams to help you say, okay, well, how are we going to get this in production? Do we need a production system? Do we build it ourselves? Do we go buy it from a vendor? So to champion one of these efforts, what you want to have is the business buy-in, right? Because at the end of the day, We do this for some sort of business buy-in, and that's what it allows. So like the core of it is kind of showing that value so that you can like get the DevOps team on board, the IT team on board, the different teams on that. And you want to start with a small project. That's what I always tell people. Start with the smallest project that you can get into production as quickly as possible. If that path to production is, deploying it to an online service, running it internal, whatever that is, because once you can actually show the value, and we have data to prove that once value is shown in one of these ML efforts, the budget almost immediately increases the next year for being able to do these types of investments. So it's this kind of concept of the crawl, walk, run, where you want to show value as quickly as possible. So versus focusing on all the things that you could do with machine learning, what is the fastest path to a value so that I can actually evangelize that? That's where I would say you start. So some enterprise considerations for those of you thinking about, okay, we're about, so it seemed like there was a, about 6% of people who are currently like, creating models, and then there was about a 12% of people between 2 and 11 in production. So these are the things that you really want to be thinking about. I want infrastructure agnostic deployment. So today you might be a happy customer of AWS. Tomorrow you might want to move over to Azure. The day after you might need on-premises solution because of security concerns. So really think about machine learning and your analytics as infrastructure agnostic. You really want that. Think about how you're going to achieve collaboration, how you're going to achieve pipelining. Start thinking about, if I have different performance SLAs for my models, how am I going to actually be able to tune my system to be able to provide those SLAs? If you have a regulatory compliance, how are you going to actually do the entire process? Governance kind of falls into that. If you're centralizing, so in the world of BI, there was a lot of centers of excellence that were built. And so especially in those centers of excellence, which don't usually fall under anybody's P&L, being able to do accounting and chargeback tracking becomes extremely important. So if that's the way that you're actually building out your internal organizational infrastructure, thinking about how you're going to do chargebacks and accounting is going to become really important. And then security and authentication with your, with your current stack. Like, how are you authenticating into data sources? How are you allowing people to authenticate into your, your different systems? And is that something you're going to be able to bring into your infrastructure for serving and scaling out these machine learning models?
Well, we have one follow-up question on governance. The question is, if I'm releasing these into the wild, how do I know how people will be using them and how I need to govern these?
Sure. So, well, the most important thing is to be able to actually like see who's calling what. So being able to see who's calling what and when is like the core. So monitoring tools around how different APIs are being called and different authentications. So being able to audit those things is really how you control them in the wild. And then applying role access-based control. So these people can use this, these people cannot. How you give access to the different models. So the combination of those features is really how you solve that problem.
Thank you. And with that, I think we hit most of the questions in line, but we wanted to leave a couple of minutes here. So I will hand this back to Jamila. Feel free to get those in.
So I'm not seeing any questions, but let's just give folks maybe 30 seconds or so to type in any questions they may think of right now.
Great. And if I could, one other plug, if you have questions that we haven't answered here and you'd like us to answer them later, our LinkedIn information is at the front of the deck here, which everyone will get. But you can also send us an email, info@algorithmia. I'd be happy to answer those.
All right, not seeing anything. It looks like you guys are the masters of time. Covered a lot really quickly, and it was really great. So thank you.
Thanks for having us.
Thank you very much.
Awesome. Thanks, guys. That's the close of the session.
Thanks, everyone.